In this video, we will walk you through the assembly process of this hexapod robot. Before assembly, you need to configure the servo IDs. The ID distribution for each joint of the hexapod robot is shown in the diagram. First, prepare the components listed above. Complete the hardware wiring and power deployment for the main control board. Connect the DC5521 to XH2.54 male cable to the XH2.54 power input of the ROS driver for robots. Then connect the IPX adapter cable with the small antenna to the IPX first generation Wi-Fi interface on the board. Connect the ST3215 servo cables to the board's 52643P servo interface. Finally, use the 18650 battery pack to power the board. After power-up, the board will automatically create a Wi-Fi network named HexArth, with password 123456778. Connect your device to this Wi-Fi, then enter the following address in a browser to access the configuration page. In the feedback information field, enter the corresponding command and click Send to modify the servo ID. In the command, raw represents the servo's current ID, and new represents the desired new ID. Here we take servo 21 as an example. Set the new parameter to 21. This is just an example for one servo. The ID setting for other joint servos is similar. To change to a different ID, simply replace the numeric value accordingly. After entering the command, click Send to complete the configuration. After all servo IDs have been set, proceed with the installation of the hip joint servos. Note that the installation order corresponds to the servo IDs 1-to-1. The ID distribution for the hip joint servos can be referenced in the diagram. First, use PA 2x5 self-tapping screws to secure the 6 ST3215 servos to the top cover plate. After all screws on the top cover plate are tightened, flip the body over and use PA 2x5 self-tapping screws to lock the bottom cover plate. Once assembled, perform an overall check to ensure everything is properly installed. After preparing the above components, proceed to install the HexArth front cover plate. First, secure the LED spotlight to the front cover plate using the supplied nut. Then use M1.4 by 10 crosshead screws with washers to attach and secure the acrylic cover plate. Tighten the screws to ensure the acrylic plate is firmly fixed and flat. Finally, use KM3x4 flat head screws to lock the front cover plate between the top and bottom cover plate assembly. The front cover plate is now installed. Next, install the HexArth rear cover plate. After preparing the above components, first secure the antenna and the latching switch to their respective positions on the rear cover plate using the matching nuts. Then insert the snap-fit plugs into the reserved holes on the plate. Finally, secure the DC5521 to XH2.54 male cable to the corresponding position on the rear cover plate using the matching nut. After securing, carefully check for any looseness. Then insert the PH 2.0 double-ended cable into the OLED display interface. Place the OLED display into the corresponding slot on the top cover plate. Next, insert the assembled rear cover plate into the already assembled body. Peel off the protective film of the acrylic cover plate and place it over the OLED display. Then use countersunk screws KM 2.5x8 to secure the acrylic cover plate and the OLED display together. Finally, use flat head screws KM 3x4 to fix the rear cover plate between the top and bottom cover plates. At this point, the rear cover plate installation is complete. Now proceed to assemble the robot legs. For this tutorial, only one leg is demonstrated. The other legs follow the same procedure. The leg servos must also be assembled according to their respective IDs. Here, the right front leg servos, ID 22 and 23, are used as an example. First, use PA 2x5 self-tapping screws to secure servo 22 to the HexArth hip joint connector. Then use the same PA 2x5 self-tapping screws to attach the lower leg connector to servo 23. Next, use M3x22 hex socket screws to secure the carbon fiber tube and tube clamp to the lower leg connector. Then insert the black round cap as a seal. After that, use M3x4 hex socket screws to join the components into a complete leg structure. And connect the servo cable. Finally, use M3x4 hex socket screws again to attach the entire leg to the hip joint position. The other legs can be assembled following the same steps. Now proceed to install and wire the main control board. First, take two 52644-pin servo extension cables to connect the hip joint servos on both sides, and also connect the leg servo cables to the hip joint servos. Then connect the servo cable harness to the ROS driver for robot's driver board. Next, connect the antenna, LED light, OLED display, and latching switch XH2.54 interfaces to the corresponding ports on the board. Then install the standoffs onto the top cover plate, M2.5x6+3 at the bottom, and M2.5x5+5 at the top. Place the ROS driver for robots onto the M2.5x5+5 standoffs, and secure them with M2.5x16.6 standoffs. Then use countersunk screws KM2.5x8 to fix the top cover plate onto the M2.5x16.6 standoffs. Finally, use countersunk screws KM2.5x4 to secure the battery isolation plate onto the M2.5x6+3 standoffs. At this point, the main control board installation and wiring are complete. Next, install the battery and the bottom cover plate. First, connect the DC5521 male to XH2.54 female adapter to the charger male connector. Connect the male connector to the battery pack, and then connect the DC5521 male connector of the battery pack to the female connector of the latching switch. Then arrange the battery pack and cables inside the body. Screw the M3x20+4 standoffs into the corresponding holes. Finally, use black metal button head hex socket screws M3x4 to secure the bottom cover plate to the standoffs. At this point, the mechanical assembly of the HexArth is complete. Now set the servo neutral position. When the initialization program runs, it will move the servos to their neutral positions. If the neutral positions have not been set, the initial positions may be misaligned. If you power on directly without setting, some servos may exceed their mechanical limits, causing stalling. Therefore, before powering on, use a Type-C cable to connect the main control board to a computer. Wait until the last line of the OLED display shows the voltage value. Then press the power switch. This indicates that the initialization program has completed. Finally, manually adjust all mechanical joints to their standard neutral positions. Now set the neutral positions through the web interface. First, connect to the HexArth Wi-Fi and enter the following address in a browser. Then enter the above information in the feedback information field and click Send. Here, ID 254 is used because it is the broadcast ID for servos, which allows setting the neutral position for all IDs on the bus at once. After restarting the device, the robot joints will move to their initial positions. At this point, the HexArth assembly and configuration are complete, and the robot can be controlled directly through the web interface.